Hello, we will now talk about the Chapter 2 review worksheet. And so if you want to try to do these problems and pause the video and then check your answers, but I'm going to go through this. And so Chapter 2 deals with location, things like percentiles and then a couple of important distributions, the uniform distribution and the normal distribution. So number one says the times to run a 40-yard dash for a group of athletes is shown below. What are the percentile in the z-score for 4.6? So here's these athletes. So the percentile is the percent of values that are at or below a value. And so 4.6, let's count the number that are below it. So it's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 below it, and there's a total of 9 values. So the percentile is going to be 8 over 9, which is 8 over 9, which would be the 88.89th percentile right there. So that is how you find percentile. It's just the percent of values that are at it or below it. Then for the z-score, the formula for z-score, which you have to memorize, is just x minus mu over sigma. It is your value minus the mean over the standard deviation. Sometimes you'll see this written as x minus x bar over s, which is effectively sort of the same thing. So there's our x value. Now we have to find the mean and standard deviation. How do you do that? Well, of course, we did that in chapter 1 by using one variable stats. We could do it by hand. I mean, the mean is just the average of the numbers. So you add them up and divide by the number of numbers. And then we have a formula for the standard deviation, but you can use your calculator to do this. And so that's what we'll do. So the way we find the mean and standard deviation of this list of numbers is we're going to put the numbers in a list. So we will go stat and edit. And I put mine in list 2. So there are the values. I put them in list 2. Just type them in there, and then we'll do one variable stats. And so the way you do that is you go stat, calculate, one variable stats, and I put them in list 2. So I go second and 2 for list 2. There's list 2 right above the 2 button. See it? Okay. And so then the frequency list has to be blank or have to have a 1 in there, either way. But make sure that's like that. And so then we hit calculate, and then we go like that. And so there's the mean, 4.37 repeating, and there's the standard deviation, 0.216 repeating. And so now we just plug that into the formula for z-score. There's my z-score. So my value, 4.6, is a little more than 1 standard deviation above the mean, which is above average, but it's not freakishly so. All right, so that's it for number 1. Number 2, the times that workers at a factory spend in training each month follow a uniform distribution from 1 to 7 hours. If you randomly select one of the workers, what's the probability they spend more than 5 hours in training? Uniform means it's a rectangle. It goes straight across. And this goes from 1 to 7 hours. And so every one of these points in this rectangle represents a training time. Okay, so if I randomly select one of these times, what's the probability it's more than 5? Well, 5 is like about right here, like that. And so there is all the values that are greater than 5. And so what I like to do is to set the height of this rectangle to be 1. And I go, well, the probability is going to be greater than 5 would be the shaded area, which that's going to be 2. From 5 to 7 is 2 over the whole area. Well, the whole area goes from 1 to 7, so that's 6 from 1 to 7. And so times 1 to be 2 over 6, which is 0.3 repeating. And so that's all there is to that. That's the answer to number 2. And then it's in number 3. It says, what are the mean, median, IQR range of the times? Now, think about this. All right, this is perfectly symmetrical. Okay, this rectangle. So the median is going to be exactly halfway in the middle. So it's halfway between 1 and 7. So for the median, you could just say, well, it's just going to be halfway between 1 and 7. And so that's just going to be 1 plus 7 divided by 2. I just averaged them. So it's 4. 4 is going to be exactly in the middle. And that seems right, because if you go 3 to the left and 3 to the right, okay, you go, it would, 4 would be right in the middle. So 4 is the median. Now, since it's perfectly symmetrical, the mean is going to equal the median. And so that has to be true. It has to be perfectly symmetrical for the mean to equal to the median. So they're the same. All right, the range is just the biggest number minus the smallest. And so it's 7 minus 1, which is 6. Now, how about the IQR? That was a little more complicated. Remember, the IQR is equal to Q3 minus Q1. All All right, and so that Q3 would be the 75th percentile minus the 25th percentile, which is Q1. Okay, well, what's the 25th percentile? It's 25% of the way through this. So if I say to myself, well, the whole rectangle has a length of 6, I got to go 25% of the way through that. So if I go 0.25 times 6, so that's going to be, so if I say 0.25 times 6, so that's going to be 1.5. So I've got to go a length of 1.5 from there to there. And so that would put me at 2.5 because I start at 1. So therefore, the 25th percentile, or Q1, is 2.5. What's the 75th percentile? Well, I'll go 0.75 times the whole length, which is 6. And so 0.75 times 6. And so that would be equal to 4.5. So I've got to go 4.5 from here to here. Well, that would put me, if I start at 1 and then go 4.5, that would put me at 5.5. So therefore, my 75th percentile is 5.5, and I subtract those, and so the IQR is 3. So that one was just a tad more complicated. So that is so that's that. Number 4, and so this is the main sort of problem that in this chapter. It says the weights of the bears in a forest vary approximately normally with a mean of 500, standard deviation of 30. If you randomly select one of the bears, what's the probability that weighs more than 520 pounds? All right, so and it asks us to draw the curve showing the shading and the z-score. So let's do that. So to draw the curve, which means I draw this bell-shaped curve, a normal curve is a bell-shaped symmetrical curve. The middle of it is going to be at 500, and then one standard deviation is 30. Okay, and so if I so label this as normal, label it as normal. All right, then if you go halfway down this hill to this inflection point, that's going to take me to one standard deviation above the mean. So that'd be 530 in this case. If you go one standard deviation to the left of mean, that would take me down here. So that would take me down to 470, like that. So there I've labeled it. And then, so that is doing the scaling. And so what's probably, if I randomly select a point in this curve, what's the probability it's going to be more than 520? Well, 520 is about right there, I would say. So right about there is 520. And so the shading is this right there. So I need the shading. Okay. So the probability, I mean, the whole area under this curve is 1. So if I can just find the area of the shading, I've got the probability. So, so the way we find now, it asks us to find the z-score as well. So let's go ahead and do that. So the z-score is equal to my value, 520, minus the mean over the standard deviation, which is 30. And so that'd be 20 over 30, which is 2/3. But and the way to find this shading is normal CDF. So I will show you that in a second. So, and the shaded area starts at 520, and then it goes to the right forever to infinity, like that. And then we put our mean and our standard deviation. This is considered showing your work right here. Label this as LB for lower bound, UB for upper bound, mu for the mean, sigma for the standard deviation. Writing that is showing your work. And so let's do this. All right. And so the way we do that calculator function is we're going to go to the distribution menu, which is right above the vars button, right there. That's where normal CDF is. So I go second distribution, second vars, which is distribution, normal CDF, right there, the second one. And so we are going from 520 to infinity. So I go 520 to infinity. So you can just hit like any sort of big number and be fine. And then 500, and then 30. And so then some calculators immediately take you to that screen. And so you just enter those 4 numbers with commas in between them. And so that gives me my answer, which is 0.25249. Yeah. And so that's how you do a normal CDF problem. And so we got a couple more of those, I believe. Number 5. All right, so in number 4, if you randomly select one of the bears, what's the probability it weighs less than 430? So less than 430, so in regards to number 5, so that's going to be normal CDF. So less than 430, so 430 somewhere over here, kind of on the tail. So less than that would be that. So my shaded area, my lower bound is negative infinity. It goes on forever. My upper bound is 430. So I will put negative infinity to 430, r minus 500. Our standard deviation is 30. I label this as LB for lower bound, UB for upper bound, mu and sigma. And so there we go. So I go back to normal CDF, second distribution, second vars, which is distribution, normal CDF, negative infinity. So the way you enter that, just enter this negative sign, not the minus sign, the negative sign, negative. And you just hit like 9 million or something like there, just some really small number. The upper value is 430. My mean is 500, standard deviation is 30. And so that gives me 0.009815. So it's not very likely to happen. I mean, in general, values that are way out of the tail are really unlikely to happen. And so that's the case here. It happens less than 1% of the time. Number 6. So number 6 asks, if you were to randomly select one of the bears, what's the probability it weighs between 490 and 550? Well, that's going to be normal CDF. So my lower bound is 490. My upper bound is 550. Mean of 500, standard deviation of 30. So this is my lower bound. That is my upper bound, mu and sigma. If those are the right numbers, yeah. And so here we go. And so we shall say second distribution, normal CDF from 490 to 550. That means that's standard deviation, and we get 0.58277. 0.58277. Like that. So there we go. All right, number 7. All right, one bear weighs less than 40% of bears. How much does the bear weigh? All right, if you think about this, all right, so this one is giving us an area and asking us for an X value. We don't know how much the bear weighs. We know that 40% of bears weigh more than it does. Okay, because it says he weighs less than 40% of bears. So this one weighs less than 40% of bears. Okay, now this one is an inverse norm problem. An inverse norm problem is when they, in essence, give you the area and ask you for the X value. A normal CDF problem is when they give you the X value and ask you for the area. And that was what was happening here. They gave us X values and we had to find the area, but here they give us the area. And so we're going to do inverse norm. And I tend to always do inverse norm with the percent that's to the left of my value. In other words, it's a cumulative value. It's a percentile in essence. So if 40% are bigger than that, it means 60% are smaller than that. In other words, it's the 60th percentile. So I'll go 0.6. And of course, the mean and standard deviation are still the same for this distribution. Label this as left area. To properly show your work, you have to label this as left area. This is mu, this is sigma. And so here we go. So normal CDF, the inverse norm is right below normal CDF. So if you go second vars, which is distribution, and go to inverse norm right there, then we're going 0.6, and our mean is 500, and our standard deviation is 30, and we're using left area. Some calculators don't have this option of left, center, and right, so I tend to always use left. If it doesn't have the option, it means it's always using left. And so we do that, and some calculators immediately take you to this screen, and you just enter those 3 numbers separated by commas. You don't have to enter left. Okay, you just enter 0.6, comma 500, comma 30, and hit enter. And so that's 507.60. So it's 507.60, and this is pounds. I like that. So that's how you do that. Number 8, what is the IQR? The IQR is equal to Q3 minus Q1. What is Q3? It's the 75th percentile. Q1 is the 25th percentile. How do you find the 75th percentile on a normal curve? That's inverse norm of 0.75, mean of 500, standard deviation of 30. That means left area. Label these or you'll get partially correct, and that's, you don't want that. All right, minus Q1, which is the 25th percentile. So that's inverse norm of 0.25, mean of 500, standard deviation of 30. And so that's, and you've labeled it once in that problem, so you don't have to do it again. All right, so anyway, so let's find these values. And so I'll do second vars, which is distribution, inverse norm. And so we're going 0.75, that'd be the Q3. That means that standard deviation left area. Boom, so that's 520.23. So that would be, so this, Q3 is 520 0.2347 minus, and then Q1, you do the same thing, or you could just arrow up here, capture that, and then go back and change this, arrow over and change this to 0.25 to get Q1. And so that's 479.7653. Okay. And then when you subtract those two guys, so let's subtract those two guys. So I'll say 520.23469 minus the answer. And so that gives me 400 or 40.469. So 40.469 about. That's my IQR. And so thus that is the answer to number 8. Number 9. Okay, number 9. What values are considered outliers? All right. Well, so what we do there is, outliers are going to be anything less than Q1 minus 1.5 times IQR. You have to memorize that formula, or anything greater than Q3 plus 1.5 times the IQR. Have to memorize these. Okay, and then in this problem, on number 8, we just found Q1 and Q3 in the IQR. And so Q1 is like 479.7653 minus 1.5 times, and then 40.469, I do believe. Okay, and so when you do the arithmetic there, it ends up being anything less than 419.06 pounds. So anything below that would be considered an outlier, or anything greater than this. So Q3 we found to be 520.2347 approximately plus 1.5 times 40.469. Okay, and so anything greater than that, make sure and put the greater than and less than signs. Greater than, and so that ends up being about 580.94. And so anything less than that or greater than that would be considered outliers. So there you go. That's it for number 9. Number 10. If you took every bear and you doubled their weight and added 10, what would the new mean of standard deviation be? So this is a transformation. All right. So if we doubled all the weights and added 10, remember, any measure of center or placement, such as a percentile, it's affected by everything. Okay. So in regards to the mean, so our old mean is 500, standard deviation of 30. Our new mean is going to be 2 times 500 plus 30. And so that would be 1,000 plus 30, it'd be 1,030, right? Okay. What would the new standard deviation be? So that's our mean, that's our mu. All right. It is not affected by the plus 10. Measures of spread are not affected by adding or subtracting. It's just multiplied by 2. And so it was 30, it's 60. So that's our new distribution right there. Measures of spread, standard deviation, IQR, range are not affected by adding or subtracting, just by multiplying or dividing. Okay, so there we go. And then number 11, the last problem for this video, one bear has a z-score of negative 2.4. How much does he weigh? Remember, z is equal to x minus mu over sigma. You got to memorize that. So we'll plug that in. So our z-score is negative 2.4. X is what we're trying to figure out. Mean is 500, standard deviation of 30. So we'll just say negative 2.4. So I hit the negative button, 2.4. So times 30 is equal to, then plus 500. And so that's 428. And so X is equal to 428 pounds. And that is a nice, quick little review of chapter 2. If you have any questions about that, please send them to me. Thanks for watching the video.